The Dassault Rafale is France's most important combat aircraft. Fitted out with French engines, weapons, and avionics, the next-generation fighter is now flying in pre-series form and serves as a flagship for France's military industries. Dassault has declared that this latest addition to its illustrious family of top-selling fighters is an ambitious program guaranteeing the future of the French aviation industry as a whole. Development of the Rafale is an affirmation of France's determination to be second to none in the Europe of the 21st century. Scheduled to enter service at the beginning of the next century, the Rafale embodies French national pride in a field of high-performance, multi-role fighter aircraft. The Rafale is being developed by Dassault Aviation, a company with an illustrious history in building successful combat aircraft, not only for France, but also for dozens of other nations worldwide. In an era of shrinking defense budgets, the ability of a single aircraft to carry out several discrete missions at the same time is taking on an ever-increasing importance. The Rafale project began in 1982 when the ACX, Avion de Combat Expérimental, was revealed as a successor to the Mirage 2000. France also participated in preliminary discussions on the pan-European Eurofighter project, but soon disagreed over several key design parameters. It withdrew from Eurofighter and continued development of its ACX. In April 1985, with the Eurofighter deadlocked, this new airplane acquired the name Rafale. On 14 December 1985, the prototype Rafale A was proudly rolled out at Dassault's St. Cloud experimental plant. Key features included an advanced aerodynamic design, 2 new Snecma M88 engines, Thomson CSF radar, a fly-by-wire control system, and extensive use of carbon fiber components. The most notable person present at Rafale's rollout was the company's founder, Marcel Dassault. In many ways, the Rafale was the culmination of his life's work. And although, sadly, he did not live to see it fly, the aircraft is a fitting tribute to one of the greats of aviation. Many new technologies were being proposed for the Rafale, and Dassault decided to prove first the viability of these advances on the Rafale A, which would serve as a technology demonstrator for production machines. Following its unveiling at St. Cloud, the prototype Rafale A was carried by road to Dassault's Flight Test Center at Istres. On the morning of 4 July 1986, Dassault Chief Test Pilot Guy Miteau-Merode prepared for the type's maiden flight. It had been accepted that the Rafale's new French engine, the Snecma M88, would not have been ready for this flight, and instead the aircraft was fitted with 2 General Electric F404 turbofans imported from the United States, and of the same type as those fitted to the FA-18 Hornet multi-role naval fighter. Preparations complete, the pilot successfully took the aircraft aloft for the first time. During the 1-hour sortie, the Rafale achieved a top speed of Mach 1.3, 11,000 meters altitude and maneuver loads of 5 Gs. The Rafale program was truly underway. Just under 3 months later, the Rafale A made its public debut at the Farnborough Air Show in England. Painted in smart and patriotic red, white, and blue colors, it had opened enough of the flight envelope to give a convincing demonstration of its flying qualities. It was evident that the Rafale retained Dassault's near-traditional delta wing layout, but with one distinct variation: inclusion of large, all-moving foreplanes known as canards. Launching an important phase of development for the naval variant of the Rafale, for which Yves Coher was project pilot, A01 made a series of approaches to the carriers Clemenceau in April 1987 and Foch in July of the following year. By mid-1989, it had made 92 near landings on the French carriers. Though unable to touch down, A01 was of great value in simulating handling on the approach. Another landmark had been passed on flight number 93 in March 1987 when A01 demonstrated a stabilized speed of Mach 2, convincing vindication of its air intake and forward fuselage design. After being laid up for rework, A01 resumed testing on 27 February 1990. This date marking the first flight of the definitive SNECMA M88-2 engine. Full-scale development of the Rafale was authorized in January of 1988, but some significant changes had to be made to arrive at production standard Rafales. The ACX had been conceived from the outset as having certain features to reduce its radar signature. One of the last-minute changes demanded by the Délégation Générale pour l'Armement before approving the design was increased stealth characteristics, resulting in the production Rafale D being hailed as the discrete model. The Rafale D designation was initially applied to all production Rafales. This has been changed since to suit the particular version and client so that the Aéronaval, the first customer, will receive single-seat Rafale M's, while the Armée de l'Air will take delivery of single-seat Rafale C's and two-seat Rafale B's. Optimization of the size, configuration, and production of the Rafale have been achieved by using very powerful aerodynamic and structural methods, and by extensive and systematic use of computer-aided design and manufacturing techniques. Rafale was designed and is being built using a 3D CAD program known as CATIA. Rafale's structure uses several advanced materials formed by exotic manufacturing techniques. Metal alloys continue to form a significant portion of the structure, and Rafale uses advanced aluminum-lithium alloys along with titanium, which has been superplastic formed and bonded by diffusion. But Kevlar and carbon fiber are used for much of the primary structure, notably the fuselage, wings, and fin. Gradually, the first pre-series Rafale took shape during 1990. Revealed at St. Cloud on 29 October, Rafale C01 is around 4% smaller and lighter than the Rafale A technology demonstrator, with several features to reduce radar signature, such as a gold-coated canopy. In Armée de l'Air service, the multi-role Rafale will replace up to 6 strike, interceptor, and reconnaissance types, including the Mirage 3 and 5, Mirage F1 and Jaguar, and the strategic strike Mirage IVP. CO-1 was delivered by road to Eastris on 31 October, and after ground running tests, the aircraft made its maiden flight on 19 May 1991. Once more, Guy Mito-Merrill was at the controls. In a busy one-hour sortie, CO-1 achieved Mach 1.2 with only one afterburner operative and cruised supersonically with only maximum dry thrust. And the aircraft took just 900 meters for its landing run. CO-1 took time off from its rapidly expanding flight test schedule to make a public appearance before President Francois Mitterrand at the inauguration of the Paris Air Show in June of 1991. This was only the 17th time it had flown. The following year, it underwent the Rafale's first official evaluation at Istres. Rafale's A and C were quickly joined by a third aircraft, the navalized prototype MO-1. The naval variant shares 80% structural and 95% systems commonality with Rafale C. But due to its operating environment, namely aboard aircraft carriers, the Rafale M features a strengthened Messier Hispano-Bugatti main undercarriage for punishing deck operations. This includes a catapult launching bar protruding from the jump strut nosewheel leg. Local airframe strengthening surrounds the undercarriage and hydraulically operated arrestor hook. In total, modifications for naval operations incur a total weight penalty of around 750 kilograms. MO-1 was most creditably only 6 days late when it took to the air at Istres on 12 December 1991. Following the retirement of Guy Mito-Merrill from military test flying duties, the aircraft was flown by Yves Caher, who is officiating in his new capacity as Dassault Military Chief Test Pilot. The final major Rafale variant to be revealed was the two-seater B-01, which was flown by Jean Frémont at Istres on the 30th of April, 1993. After a small allowance for increased empty weight and reduced fuel, the Rafale B remains fully operational. A second naval prototype, MO-2, was flown shortly after, taking the total number of aircraft to 5. 24 January 1994 marked another highlight in the flight test program. Having been instrumental in testing and verification of many of the Rafale's fundamental technologies, the Rafale A bowed out in fine style when it led a well-publicized formation of all pre-series Rafales during its 865th and last flight. Aerodynamic configuration, stealth-reducing features, and advanced materials primarily concern the Rafale's airframe. But it is the systems, engine, avionics, and weapons which give the Rafale its true fighting capability. And some of these are at the very cutting edge of aerospace technology. Rafale is powered by two Snecma M88-2 turbofan engines, each delivering around 16,500 pounds of thrust, and even more with afterburner. To give some idea of the advance this represents over previous fighter engines, this performance is comparable to the Atar turbojet fitted to the Mirage F1, except that the M88 is around 40% shorter and weighs 45% less. This gives no less than an 88% improvement in thrust-weight ratio, coupled with far superior reliability and ease of maintenance. And to compensate for the fact that combat aircraft usually gain weight during their service lives, potential is inbuilt for increasing thrust by 25% at mid-life. Perhaps the most important system fitted to the Rafale is its RBE-2 radar, which is the key to the aircraft's versatility. In simple terms, RBE-2 will be the first operational European fighter radar in which electronic scanning of the beam replaces the traditional mechanically operated nodding antenna. Built by Thomson CSF and Dassault Electronique, the radar derives its designation from a two-dimensionally electronically scanned antenna. In air-to-air mode, the radar will search above or below the horizon out to 100 kilometers and automatically select frequencies to optimize detection. During air combat, it can simultaneously track up to 8 targets and launch air-to-air missiles at those presenting the greatest threat. And greatly increased beam agility and data processors performing 1 billion operations per second allow the radar to interleave functions. So, for example, it can track and engage airborne targets while the Rafale is carrying out terrain following flight. For air-to-surface operations, the radar has terrain following, terrain avoidance, and threat avoidance capability, steering the Rafale over hills and around surface-to-air missile sites. This capability is allied to modes for updating navigation, targeting, searching and tracking of moving or fixed targets, and high-resolution ground mapping. Maritime strike will be an important Rafale mission, and long-range detection and tracking of shipping by the radar can be a prelude to attacks with surface-skimming missiles. The radar will also automatically track the Rafale's own aircraft carrier, making for easier approach and recovery. The radar is augmented by a combination of mainly passive detection and tracking aids known as OSF, Optronique Secteur Frontal. Data from these systems in the futuristic glass cockpit is presented to the pilot via a wide-angle holographic head-up display built by Sextant Avionique. This is backed up by 4 other color screens with touch-sensitive liquid crystal displays, one of which shows the tactical situation, including outputs from the OSF system. And for air-to-air combat, the pilot has an ace up his sleeve. Rafale's capability in target detection is coupled with a formidable array of weapons, up to 6 tons, for target destruction. Rafale's principal air-to-air weapon is the Matra Mika. Vanes at the rear deflect the rocket motor's effluvium and give the missile high agility. 2 types of seeker head are available, infrared homing or active radar, which gives a true fire-and-forget capability. Mika's reach of up to 50 kilometers allows Rafale to engage targets at well beyond visual range. Rafale carries a maximum of 8 Mikas for intercept missions. Mika is entering service with the Armée de l'Air's Mirage 2000C interceptors, but was ordered and developed specifically for the Rafale. The medium-range Mika is backed up by the well-proven Matra Magique II, infrared homing air-to-air missile for short-range combat engagements. Rafale can carry most of the current range of France's air-to-ground weapons, including the ASMP standoff nuclear missile. The most significant new addition is the Matra Apache, a long-range submunition dispensing missile. Power comes from a small turbojet engine, which gives it a range of around 140 kilometers during low-level terrain following flight. Anti-runway attack is the primary mission for which Apache carries the CRIS submunition. Apache can also be used to take out fixed targets such as SAM sites and communications, as well as moving armored targets. Lakehurst, New Jersey, the scene in June of 1992 for a series of catapult and arrestor wire experiments. Before the airplane could carry out deck trials on a real aircraft carrier, its specifically modified undercarriage had to be evaluated on land bases. Flown by a team of pilots from the Centre d'Essai and Vol and the Marine, led by Yves Caherve, MO1 conducted a series of catapult firings, rolling arrested landings, simulated landing approaches, and flight-arrested landings. The first set of trials exposed a possible weakness to the nose wheel, and after suitable modifications had been made to correct this, MO1 returned to Lakehurst to conduct a second campaign of deck trials. With preparations complete, the prototype Rafale M used its 200th sortie to deploy from Istres to the deck of the Foch in the Mediterranean on 19 April 1993. The first carrier launch followed the next day, and MO1 finally completed 31 successful catapult takeoff and landing sorties. To meet the balance in the projected number of aircraft sold, Dassault is actively pushing the Rafale on the export market. The company anticipates a production run of 800 to 1,200 Rafales, including the home market. This sequence, entitled Operation K-O-Zar, was put together by Dassault to promote the different capabilities of operational Rafales. The Rafale will ensure that France's armed forces will remain at the leading edge of air combat capability well into the 21st century.